So we're going to look at Chapter 10 today, Information Systems Development. Now, I often get some pushback from students about this chapter because a lot of them have trouble really trying to understand why are they learning about development of information systems. And I think there's a few really key reasons why. Let's start with the real-world decision-making here, especially when it comes to like new technology. So oftentimes, and this happens far too often, that someone will hear about this new technology or get this great idea. Hey, we need this. This Facebook thing is everyone's doing it. Why aren't we? Let's make a Facebook page for our business, right? And so this idea gets floated out there, and they talk about it in a few meetings. Eventually, they convince somebody with a budget to hey, let's pay to have this developed, this Facebook page, right? And they might pass it by the CIO or the IS director, and they agree. Yeah, sure, why not? You got some money, let's do it. Chances are, though, the CIO is basically told, "Hey, this is what we need. Can you make it happen?" And sometimes they even check to see, well, is it feasible to do a Facebook page? But unfortunately, a lot of these studies, if they're done, basically always come back of, yep, let's do it. We'll make it work, type of thing. Whether or not it's really a good idea isn't always accurately captured. So then the project begins, and as the project develops, more and more people are brought in, and you keep asking more and more questions about this project. So what are we going to incorporate, and why just Facebook? Why not Twitter? Why not LinkedIn? Maybe we can integrate all this together using a social media platform so that we can push out these new marketing plans, or this. Well, we could also put out, the HR gets involved and says, well, we could announce new job openings, and then, and then the the operations guy says, well, we can communicate with our suppliers doing this, and before you know it, it's just this hodgepodge of ideas being all thrown together, and they keep demanding changes. And so this original project, which, creating a Facebook page you can do in about 10 minutes, could end up taking months and months and months to do, and take twice as long, if not more, and take a lot more money than originally planned, right? Now, this is how it has been happening for the past 70 years of information systems development. This is not something new, right? There is actually a long, long history of massive failures in information systems development. And by failure, I don't necessarily mean that the software doesn't end up being created and being used. What I mean is it takes, much longer to develop the project than originally planned. It takes a lot more time than originally planned. Doesn't do the functionality that it was originally designed or specified to do. And this happens a lot, right? I'm not talking about 5% of the time, 1 in 20 projects. I'm talking, in some cases, 90% of the time there is a project failure of some sort, whether it's over budget, over time, lack of functionality, right? And the history of this process failing keeps repeating itself over and over and over again. So why is this, and why should you care? Well, in part, not just because you're going to use this stuff, but because you're going to be intimately involved with this process. And we'll talk more about how you're going to be involved here in a bit. But just keep in mind, you will be involved in information systems development, okay? Many times throughout your career. You will be involved. Now, the question is, are you going to help the involvement to make it a success, or are you going to be part of the problems that are causing the failures? And hopefully by talking through this, you'll see your role in this. If you do some really hard thinking up front, you can avoid a lot of these failures. So what are the top 3 reasons for project failures? Well, number 1 is this bad communication between the relevant parties. And this includes the users, such as yourself, who are using these systems but do not communicate well with, for example, the developers. Or there's poor communication between the executives and the people involved with developing the project, or there's poor communication between the people in developing this information system. 50% of the time, a project failure is due to some sort of bad communication. There's also can be a huge problem with planning. In fact, we're going to spend some time, I believe it's one of the chapter extensions, talking just about project management, because planning can help alleviate so many of these problems, and yet far too few people know how to do it and do it well. That a lot of reasons projects fail, and by failure we're using a broad definition here as over budget, over time, or lack of functionality in the finished product. Right. So even if it's completed, even if it works, but if it goes over budget, it's a failure. Right. But if you don't plan well, your schedule, your resources, your activities, that can be a major problem. And lastly, there's no quality control, or lack of quality control. And this just might be that someone produces something, but no one checks to make sure it does what needs to be done, right? And so this might be the case, like if you develop a Facebook page, well, that seems very simple, and this has actually happened in a department I used to work at. They're like, we're going to create a blog for all the faculty members to publish to. But there was no system set up for us to do it. It was kind of just, we'll put this out there and hope you guys will use it. Well, nothing happened, right? There was no quality control built into the system to make sure that people are regularly submitting things of good quality. And that can happen a lot in information systems development. And it's not that the programmers are doing a bad job. Sometimes when they complete, they're not as rigorous about finding bugs as they should be. And then this actually happened to me as a developer at one point, where I was involved in a project, and I was kind of leading the project, the development side of things, but I did not understand the importance of quality control. And it came back to bite me in the butt when I had to work all weekend. Actually, it was my birthday, was the weekend. That's how I remember it so well. And I spent probably 20 hours on the weekend just going through and debugging the system, because I did not put enough emphasis on quality control prior to when we were supposed to go live. And so, it came back to bite me in the butt, right? So that was a project failure. And so I know from firsthand experience what can happen if you don't have quality control, right? But so where does this usually fail? Well, it usually actually fails on the largest projects have the biggest failure rate. And it was estimated that on projects from $6 to $10 million, that over 92% of them are considered a failure, meaning they took overtime, over budget, or lack of functionality. On smaller projects, it's a little bit easier to handle, but there's still 50% of the time there's a problem, right? So imagine this: you're working in a company, and they have a new, they're like, oh, let's use this new piece of software, but just because someone wants to use this software doesn't mean it's a good idea to do it. So preferably what you can do, if there's a problem with a project, that you can identify it early and fix it early. So, and if you look at projects when they are abandoned, over 60% are during the development or implementation phase. Now that's after you've already spent a whole ton of money on it. Ideally, if there's a problem with a project, you identify it early and get out before you sink a whole bunch of money into it and then find out it's a waste. All right. So that's kind of what we're going to be talking about today, is what is this process, because there is a set process for going through this, but also what is your role in this process to help it be successful. So the study questions for Chapter 10, what is systems development? All right, so we'll give a definition. Why is systems development difficult and risky? So we'll talk about some of the specifics about this. Why there's so many failures. What are the 5 phases of the systems development life cycle? That's the SDLC, Systems Development Life Cycle. And you'll probably have to remember that, so mark that down. How is systems definition accomplished? And if you don't know what that means yet, we'll get to it. What is the user's role in the requirements phase? How are the 5 components designed? How is information systems implemented? What are the tasks for systems maintenance? And what are some of the problems with the systems development lifecycle? All right, so there's actually quite a bit we're going to cover today. So take some time. If you get bogged down in studying this, stop, reread it. If you have questions, please post it to the discussion board. But take your time with this, because it can be a little overwhelming at first, right? And that's to be acceptable. But there have been so many failures in systems development that we want to help you guys make it a success as you leave and go out into industry. All right, so let's start. What is systems development? So it is basically a process, right? It's the process of creating and maintaining information systems. So we talked about, what an information system is, right? So it's got these 5 components. And, at some point, we identify that whatever our current information system is not adequate, and we want to create a new one. So this is the process of creating a new one, and then after it's created, we have to maintain it. So it doesn't just magically keep going. There needs to be people at the back end who are maintaining it. It's kind of like after you create a Facebook page, right? Creating it's easy, but how do you maintain the Facebook page that it stays, keeps up with new technologies, or keeps up with changes in personnel, or keeps up with adjustments that Facebook might make to their policies and procedures. So, at any rate, we got to maintain, right? All right, so how do we do this? Well, 4 big things. You need to establish the system goals. So, all right, what are your goals for this? And this is part of the business process. So you got to understand that business process, but it's also, what are your goals with this process? Are you making it more efficient, more effective? Are you trying to eliminate people that are roadblocks? Are you trying to so there should be something specific you're trying to accomplish by this, right? Then you need to set up a project, right, to get this done. So after you know what you're going to do, you have to you have to create a project around creating this system. Third, you have to determine what are the requirements that allow you to accomplish those goals. So these are specific. You might think of them as specific objectives, things that you can say, it needs to be able to do this. It's required to do this, or else it's a failure, right? And then lastly, you need business knowledge and management skills to get the job done. All right, so what is systems development? It's the process of creating a new information system and then maintaining it after it's created. So why is this so difficult? Why do people, why is it that so many projects are never finished, and those that that do finish are often sometimes 300% over budget? So it costs 2 to 3 times as much. And there's some projects that finish with budget and schedule but can't accomplish their goals. And even with competent people, found an accepted methodology, there's still a high risk of failure. So why? Why do we have these problems? So here's some of the major challenges. Well, number one is the difficulty in determining the requirements. Now, you might be saying, well, why is this a big deal? Well, think about this. If you're developing a system that is going to take, that's going to incorporate, hundreds of employees in the organization, how can you develop this system to make sure that these 100 employees all can still get their job done? So you have to understand oftentimes many, many, many different business processes. And sometimes you're changing that process. Well, how do you know, if it's a success or not? And maybe you try to define a process, change the process, but it's not done well, or there's no checks and balances done so that somebody can let things slide. It is actually very, very difficult to determine the requirements. And some people will, when they're getting involved with this, will give very short or unclear ideas of what is required. So they might say, someone might ask them, is there anything you need to know from this new system? And their first response is, well, no, I just need a report. Can you give me a weekly report, right? Well, that might not fully capture what they really want to get out of the system. Really what they want is not just a report, but the ability to drill down into individual items on occasion. And so that's the big issues here is when do you have these on occasion things that you want to be able to do? Kind of ad hoc. So that's always an issue, right? Number two, there's a lot of times there's changes in requirements. So for example, especially for bigger projects that might take a year or two to develop, oftentimes there's going to be new things that come out, whether there's new technology, new employees, new goals and objectives coming down from senior management. Things are changing in business, always changing. Sometimes the competitors come out with new products or new services, and you have to adjust, right? So that's going to impact your information system. But if you're in the middle of development and suddenly things change, that's going to cost money to make the changes. Changes just don't happen magically, right? It costs more money. Often, again, major difficulties with scheduling and budgeting. If you're working with, 5 people, it's a little bit easier to deal with, scheduling their time. But if you have, let's say, 20 different executives that have to get together and discuss something, it's very difficult to find a time when all 20 of them can meet and discuss this thing, right? So scheduling time to put these pieces together, making sure you have an accurate budget for what's needed. Now, things like buying a product is pretty easy, but if you're buying or if you have to hire a consultant, how much time do you need from that consultant? And what happens if you hire a consultant, let's say for a month, but they don't complete all the requirements that you've assigned to them? What do you do then, right? There can be changes in technology, So, you might decide we need to develop some new apps for the iPhone, and then the Android comes out with their new system, and you're like, well, now we need an Android app too. And maybe Microsoft and their system, which not a whole lot of people use, but you might, well, we need a Microsoft app too. And so as technology keeps changing, you have to change your information systems to adapt. And then there's something called the diseconomies of scale. And we'll talk a little bit more about this here in a minute. All right, so let's dig into the difficulty of requirements determination, because this is so huge, right? Trying to define specifically what is the system to do. What exactly? So, for example, if you look at the PRIDE system they talk about in the beginning of the case, the doctors have to decide exactly what type of reports they need to see, or when do they need to see them. All right? Will they have both standard reports and exception reports? Now, if you remember what an exception report is, basically they only receive the report when there's an exception to the rule. So if, for example, somebody doesn't do their workout, or if somebody's training too hard and looks like they might have a heart attack, they need a report immediately, right? So are these reports fixed in structure, or can the user adapt them? In other words, do you need to let them customize the reports? And how? How much customization are you going to allow them to do? Because that's going to cost more for you to develop. But oftentimes, if you give them just the fixed structure report, it's very limited and not very informative and may not really help them make better decisions. So if you want to get to the business intelligence, like we talked about in Chapter 9, you want them to get as much intelligence as possible, to get the information they need to make good decisions, to solve problems, to plan better, and to be informed about what's going on, right? So there's this trade-off. A trade-off between the scope, in other words, how big the project is, and the cost and the time. All right, how many practices and how many patients per practice will need Pride support? Again, back to that case, So this is important to understand. How big is this system? So in other words, how much technology do we need in the back end to support this? Are we expecting it to be 20 patients, or do we expect it to be 2,000 patients, or even 2 million patients? Because this will impact how you develop the system. If you think there's going to be 2 million patients, it needs to be able to handle high bandwidth, lots of processing, which can be very expensive, but it also is a different way of development on the back end when you're developing the software to find efficiencies. But by doing that, you may have to limit some of the capabilities of the system. So, and I was involved in this, developing this project management tool, and that's a major question. Is we had a web-based solution, but we actually had to mix up how our solution was, or how our web pages were created, and certain reports that we created. In fact, some of our reports were actually done nightly. So we decided that the processing power, we couldn't make it real time. It was too processor intensive. If someone clicked on a link and it took them, a minute for a report to load. However, if we ran these reports in the middle of the night, a minute's not a big deal in the middle of the night when nobody's using it, and then the report shows. All right, so knowing how these things are scalable is very, very important. And then you also have to ask things like, do we need any cloud resources? All right, so do we have to create an environment where difficult questions are asked and answered? All right, what about changing requirements? So systems development aims basically at a moving target, and I think that's the key here to realize is that the business continues to move on. It's not static. It doesn't stop. And some businesses move a little bit slower than others, and that's to be taken for granted. But no business is sitting still. They're always changing, developing, looking for new products, new services, new personnel, but also new business processes or changing business processes, changing requirements to make those processes work. And the bigger the system, the longer the project, and the more requirements are going to change. And that's basically a given within every systems development. So, how does a development team deal with these changes? Now, it's important to also recognize that, yes, these changes will occur. There's going to be somebody, a new executive maybe, that steps in and says, we need this system to do this. We cannot go live unless it does this, or this, or this. And that's just part of the process you have to deal with. We should not just throw up your hands and say, oh, well, I don't know what to do now. Right? We have to adapt, and that's where having a process for dealing with changes is absolutely essential. Okay. All right. So you have to incorporate changes, build, complete, and make changes in the maintenance phase as well. So, in an example for our Pride system, what happens if, in the middle of the development process, a major health club shows up and says, hey, we have this lucrative contract proposal. We want to be included into the Pride system. And we're willing to throw some money at it too. So this is a major change from this health club, and we want to include their reporting requirements into it. So that's the type of thing that can happen, right? So you get this very lucrative contract, and you don't want to pass this up. But that means a change in your system. And so then you have to decide how are you going to make that work. All right. Scheduling and budgeting difficulties. Now, what you may not realize is writing software is an incredibly difficult process to judge how long it'll take. You're basically asking someone, how long will it take you to solve a problem? And yes, sometimes you can estimate, especially if you get pretty good at you've done it for a while, but it's inherently an unknown, right? How long will it take to actually create this little module for our software? Or how long will it take to create a data model? right? And you don't necessarily know what all the requirements are yet. So you're creating this data model, and you might realize when you're halfway through, you need to go back to the user and ask them, is this right? And they say, no, we got to change this, this, and this. But you didn't expect that. So now suddenly things take longer than originally planned. And this is almost always occurs in software development, is things always take longer than what they expect. Now, again, when I worked in industry, I had a manager of mine once said, he estimates how long it's going to take, and then he triples it. So he thinks, how long will it take me to develop this? I'll make that 3 times longer, and that's what I'm going to put as how long it'll take, right? Because he knows that inevitably something's going to come up that he didn't expect. And so he cushions his estimates by that much every time, right? So there's all these different scheduling and budgeting issues that occur here. And I'm not going to read through all these different questions because you can kind of do that yourself. But making these estimates are incredibly complex and do take a lot of time. All right. Changing technology. So, do you want to stop your development to switch to new technology? Right? So, and this can be something as innocuous as a new release. Maybe you're developing your system to work with Microsoft Excel. So you're going to send your data to Excel so that you can print out certain things. Well, that's great, but what happens if Microsoft comes out with a new version of Excel? Now, do you want to stop what you're doing here and change to the new version of Excel? Or what if, somebody else comes out with this brand new technology, maybe Google Docs, that's now free, so you don't have to pay for it. Well, do you want to switch to Google Docs or stick with Microsoft Excel? So there's always this constant innovation that's going on in technology, as you're well aware. But when you're developing a new piece of software that's going to integrate with a lot of other pieces of software, that is always a constant question. How do when do we switch to this new technology? Especially if you're in the middle of a project, is it worth it? Or would it be better to finish developing according to the existing plan and then maybe update our software later? But then the obvious question is, why build an out-of-date system? And can you afford to keep changing the project? Right? Not easy questions. All right, and the last one, the diseconomies of scale, which is basically means that if a project is having problems, trying to throw more people out to fix it doesn't always work. It's not like you're building some new factory or you need to hire more employees to create more widgets. Now, Brooks Law actually came, I believe Brooke was an IBM manager who was in charge of developing the 360 operating system back in, I want to say the 60s, maybe early 70s, the operating system for IBM's mainframes. And it was a new idea at the time that they were going to have one operating system for the entire lineup of their mainframes. So they had very large mainframes to small mainframes. And I think there was like 5 different sizes. And they wanted to have one operating system that would work on all of those. So when people developed software for a small mainframe, it would also be able to work on a large mainframe. So the idea is they wanted to be able to develop pieces of software that would work on all their different sizes of mainframes, which is something new they hadn't done before. And so Brooke was in charge, I believe, of developing this operating system. And they had developed a timeline for when this was going to be done, and they started working on it. But they started having problems. And so they were told, well, hire more people, get this project done on time. So he hired more people, but the project took even longer. And then he hired more people, and they had to delay even more. And what he realized is that more and more software developers, so he kept hiring all these different software developers and trying to add them to this project, actually made the project take twice as long. And it did. It took twice as long to finish. So this is a diseconomy of scale. So the more people you add, the longer a project is going to take. And specifically, the more people you add late in the project. So if you had all these people trained right from the beginning, it might have been a different story. But adding them as you go is inevitably going to cause problems. So new staff, here's the problem. So here's where it comes in. New staff must be trained by productive members. So in software development, if you have some people doing software development, they have to train the new people coming in. Well, that means the productive members, the software developers, have to stop working in order to train these new people. So they lose their productivity. And the new staff can't be productive until they've been trained up. So for a while, nobody's doing anything. Now, schedules can only be compressed so far. Now, we've developed a lot of techniques so that it's easier to add people to a project, but there's still problems with this. So once a project is late and over budget, there are very, very, very few choices as far as how to get it done. And that's part of the problem. One of the reasons why there's so many failures is that if you misjudge how many people it'll take, oftentimes it can lead to a disaster for a project. All right, so software development has had these issues for many, many, many years. And they, over time, have developed a system for trying to get this done. And they called it the Systems Development Life Cycle. Now, in the Management Information Systems Department, our primary objective is to train systems analysts. Although we do other things too, but that's kind of one of the major employment functions of our graduates usually end up doing. And their primary goal in one of our capstone classes is basically teaching them how to go through this process. So the idea between what a systems analyst's role is to start with a systems definition, defining what it is they're trying to accomplish. Then their goal is to gather all the requirements for that analysis. Then they start designing the components. And they usually often do this in conjunction with the software developers and the business people to make sure the components are designed appropriately. Then they help with the implementation, and lastly, the maintenance side. Now, the traditional systems development lifecycle, used to call it the waterfall approach, which basically means, and if you kind of see, it's like a series of waterfalls. So finish one, then it falls down to the next one, and finish, systems definition, then it goes to the requirements analysis, and then the systems requirements analysis. Once that's done, it waterfalls down to the component design, and after component design done, it waterfalls down to the implementation, and so on. So you have a finished system, and then users start using it. If there's a problem or changes, it goes into system maintenance mode, and changes are made if necessary. All right. So let's talk about the systems definition. So the systems definition basically is where you assign a team to define the new system, assess its feasibility, and to create a project plan. So this is where you basically set the scope, the boundaries, and to see, is this really a project that we need to do? Now, ideally, what you have is some sort of committee in your organization who can help. So oftentimes, especially the bigger the business, the more ideas for systems will be created, right? So there's usually no limit to the amount of new systems that a business can or will want to do. So the needs are infinite, but the resources aren't. And so you need a way for a group of people in the organization that can help define which projects or which systems, information systems development should go forward. Where should they put the money? So that's something called the steering committee. Now, a steering committee will help in this process, but what you need in order to get to the steering committee is you need to define what this system is going to do, assess is it feasible. So you have to look at the technology. Does the technology exist? Is it something that the users would actually use? Is it something we can afford? So an economic feasibility. And is not just can we afford it, but is putting money into this system better than putting money into a different system? But then also say, okay, and if we go forward with this, do we have a plan for this project? Do we have the employee resources, or can we get a hold of consultants at a reasonable rate to do this? And once you go through this process, define the system, and it gets approved, then you create your project team, which is going to consist of both users, the people that are going to use the system, and the IS professionals. And so in our example, in the case, Dr. Flores hired Maggie, who's an independent expert, to work with partners, staff, and patients to define the PRIDE system. So they define what are the requirements that are needed. I'm sorry, we haven't got to the requirements yet. We're just defining what is this project basically going to do. We haven't got all to the specifics yet. But when we define the feasibility, basically there's four main dimensions: cost, schedule, technical feasibility, and organizational feasibility. And organizational can also include things like, is there support from the executive team or the people who are going to be using it? And so oftentimes you'll have people in some organizations that people just don't want to do things, or if they're not required to do it, they won't do it. And this can happen oftentimes, like at the university, right? Getting faculty to use a specific system can sometimes be difficult. In fact, at ECU, when it comes to classroom technologies, we're not required to use any technology specifically in the classroom. So what the university does is gives us a bunch of options and say, hey, you can choose. You can use Blackboard. The university will support that. We'll include things like Saba Meeting. We'll give you Yammer. We'll give you Tegrity and MediaSite, and a lot of these different technologies that we could use. You can use clickers. You can use, in some classrooms or smart classrooms, they got all these different technologies in there. But that's how it works at our university level, right? So when you're looking at organizational feasibility, part of that is, does the organizational support it? Now, if all the faculty were required to use Blackboard, you're probably going to end up getting some pushback from a number of faculty who will say no. And what can you do about that, right? It might end up just pissing people off. And there's also legal requirements. So recently there were some laws passed in the healthcare industry, one is called HIPAA. And then I believe even Obamacare had some requirements that hospitals had to start doing as far as how they implement their technology in their organization. And these legal requirements, obviously, even if the organization may not like it, so doctors might be like, well, I don't want to do this, but if they're told, yeah, we have to. The law says we have to do this, otherwise we shut down the hospital and you lose your job. So yeah, sometimes you have to do it, but it's important to identify exactly how feasible is something. All right. So even if once you have your project team, you have to realize that the team is going to change over time depending on who you need to do specific parts. So specifically like early in the requirements definition, which we'll get to in a second here, you're going to need a lot of time from the business and systems analysts, and particularly working with a lot of the users too, to try to get a clear idea of what needs to be accomplished. But later in the design and implementation, you don't need such a heavy emphasis on the analysts and the users. Now you need much more effort from the programmers and testers and database designers. But then after you design and start implementing, you need someone to test it. Well, this is where you need people called testers and even the business users themselves. So users have a very active involvement and should take ownership of a project throughout the entirety of it. If they don't, you're going to end up getting something that they don't want, right? Because they weren't involved. So, and this is another reason why this can be a very difficult process, that the people who are involved with a systems development project change over time. All right, so what is the user's role in the requirements phase? So after you got the systems definition, we have to gather the requirements. And so the requirements, again, are basically specific things that the system should do for the business process. So how does that accomplish? Well, you can do things like conduct user interviews. You can evaluate the existing systems. So how are things currently done? But then you have to start asking things like what type of new web pages, forms, reports, queries are we going to need? Identify new application features and functions, consider security, create the data model, and all 5 of those components: hardware, software, data, procedures, and users. You know, do we need new hardware? Do we need new software? Do we need new data? Do we need new procedures for how people interact with each other? And do we even need different personnel? Right? And once the requirements analysis is done, and done well, it gets approved and sent on to the component design. Now, keep in mind that requirements definition done well is expensive and very difficult. Done wrong, and the resulting system will be wrong. Right? So done right, it's expensive. Done wrong, and you get the wrong system. So it doesn't leave you many options here, right? So, but the important thing is, I want to emphasize, though, is you shouldn't rush through this process. And so as a user, you have a very integral role in trying to make sure that this system is actually doing what you need it to do, and do it in the way that works for you and not against you. Now, hopefully, and this doesn't always occur, so this is a specific type of project. Not all projects do this, but hopefully by this point, once the requirements are gathered, you can start putting together a prototype, which provides a direct experience for users, provides evidence to assess technical and organizational feasibility, but is used to estimate development operational cost. So you can think of it as, you know, the rough draft. Is they throw something together. It's not real good, but you put it together, have people take a look at it, and some rough drafts are some prototypes are very, very, very stripped down, but just enough bare bones so that people can touch it, actually play around with a little bit just to get a feel for what its potential could be. Now, the reason why you want to do this, though, is to keep the users involved with the development process. So now we talked about this, traditional systems development lifecycle. We saw that, when you finish the requirements analysis, you're supposed to go to component design. Well, what happens if in the component design, things are designed not quite, so maybe the requirements analysis wasn't quite perfect, so the design isn't quite perfect. So over time, a lot of developers realize this, and they've actually come up with new methodologies. One in particular is called a rapid application development, where you start with a prototype, but you continue to develop this prototype over many iterations. And the idea is you design a prototype, you implement it, you test it, but then you hand it back to the users, and the users can then test it and see, is it doing what they want it to do? If it's not, hopefully you can identify the problems early in the development process and fix them. So yes, oftentimes there's going to be a lot of requirements changes, but it's better to get those requirement changes done early than it is late in a project. It's far less expensive this way. Now, a lot of web development actually uses this process, the rapid application development, because it's easy to publish a web page or a website. And you can quickly get feedback from the users as they click around on a website to see how they're using it. So a lot of web applications are done this way. All right. Going on here. Question 6. How are the 5 components designed? So remember the 5 components: hardware, software, data, procedures, users. Well, I mean, at this point, once we have the component design, or the components, the component design comes from the requirements, right? So, like, for example, do we have enough hardware to do what we need to do? And sometimes you do, sometimes you don't. So, for example, I teach a web development class, and we needed, so for our class, we actually wanted students to develop websites, and we wanted a place where they could upload their work onto a server. Now, originally, we actually had a server within the College of Business, but we realized over time that this wasn't meeting our needs. And so we actually contacted the university IT department and said, do you have some server space where we could use for student projects? So at this point, we had to do, the component design said, all right, do they have the hardware that we can need and the software specifications for us to create a server for our class? Now, the database design and procedure design were things that we actually developed. I helped develop, and we also have. I was working with Dr. Schwager, and we worked on that together. The database design, procedure design, for this courses that we were teaching. So we actually did the rest of it. But the point is, though, you have to determine, do we have what we need to do? I also worked with some projects doing systems development. And like they talked to a law firm that had a lot of paper documents that they thought it'd be nice to get rid of all these paper documents and make it all digital. Well, how best can they do that? Well, they found out that they don't have good software for that. They do have a scanner, but it's a cheap scanner. And when you have thousands of documents, you don't want to have to scan one document at a time, because it would take freaking forever. So they could buy a very heavy-duty scanner that can process, hundreds of documents a minute. But that's expensive to have to buy one of these things. And once they're done with their scanning, do they still need them anymore? Probably not. So they could also rent one of these. So again, we're getting to hardware specifications here, right? So a lawyer with lots and lots and lots of paper documents wants to digitize everything. How do they do it? Also, this hardware would have to be complemented by software that would not only take the scanned documents, but then sort them and file them correctly so that the lawyers can find it and use it, access it easily later. So they had to make sure there was correct software. Then they also had to make sure there was a database to store all this digital copies, right? Then there's the procedures. How did the lawyers want to be able to pull information out? What were the procedures for scanning documents? What happens if some of these digital documents were lost, or if they, how do you deal with the failure of the hardware? So you have to create procedures for that. So it's all very complex, all these different things you have to do here. So once you have the requirements of what it needs to do, then you have to look at the components and actually determine the exact specifications of how you're going to do it. So the design phase can be very complex. It's returning those requirements into a specific information system design. Once you have the design, then you can actually start building your system, and that's called the implementation. And I shouldn't say just build, because sometimes it's also about purchasing the correct software or hardware, and then integrating it within whatever you have existing. So like suppose this, you go back to that law firm and that they're digitizing all their paper documents. Well, they may already have some of the components that they need. So they don't need to buy everything, but they do need to buy some. The question is, what do they need to buy? How do you integrate it together? So you might need some software built to integrate things. Then you need to test everything too. So part of the implementation is actually testing. Does it do what we want it to do, exactly how we planned it? Because if you don't, you can have major issues. So maybe they start scanning documents, and then what happens after they scan them? They shred the documents, and the documents are gone. Now what? Okay, they probably wouldn't shred them. They'd actually probably put them in a warehouse somewhere. But still, the point being, how are you going to make sure that this is working? Absolutely essential. Now, to do that, to test things, you need to test and test and test. In fact, for bigger projects, you often have like a product quality assurance, which is a set of requirements. So you go back to the requirements. So we did this requirements analysis of what is required in the system, and you basically check each one of those. And the requirements can span not only the user requirements, but also technical requirements. So it needs to be this fast with this heavy load. But then you also only have the user testing, so the user tests. And there's all different types of bugs that could develop, not just with the code, but also with the output. So maybe you create the code and the formula for calculating net present value is wrong, right? It could be mistyped into the system. So a certain important equation could be mistyped. So the user needs to not only test to make sure that things are coming out, but they come out exactly as they expect them to come out. And this can be difficult to find these kinds of errors, because a lot of times people just look over and like, yeah, looks good enough. But they don't realize that maybe the numbers are coming out are just wrong. And how would anyone know unless you specifically sat down and said, all right, are these the right numbers coming out? I'll calculate them by hand and then compare it to what comes out of the system. And sometimes the only way you can do that. And lastly, you need beta testing. So this is the final say on whether a system is production ready. Now, you've probably heard the term beta testing before, or you've heard of software that's in beta. Basically, it just means that they think they have it. This is basically when the software developers and the information systems department says, "All right, we think it's done. We think we covered all the requirements, but we want you to do one last thorough test." And if it passes this beta test, we'll go forward. Now, that being said, there's always bugs. Every piece of software that's shipped today has bugs in them. And I want to emphasize that point to you guys. Every single piece of software that is shipped today has bugs in them. And that's not because of incompetence of the software developers or anything like that. These are very, very intelligent software developers. However, when you're working with large, complex systems, things inadvertently don't work the way they're expecting or expected to. So what a beta test does is let's find all the biggest, most important bugs, and so we can fix them. So that, yes, there's going to be some minor things here and there, but hopefully nothing major. All right. So once testing is done, then it's time to make it go live, to what they call production ready. So what happens there? Well, there's multiple different ways you can do this. So probably the most dangerous one is what's called the plunge implementation, which is you turn off the old system and start the new system. Now, sometimes you have to do it this way, but it is all very dangerous. Now, for example, this past summer, before the summer session started, Blackboard went through an upgrade. and they decided they had to do the plunge implementation, basically. Now, they did have a pilot. Actually, I shouldn't say that. They already did have a pilot. So they had a small group of people working with it. But then they shut down the old version of Blackboard, and everybody started using a new one. So I guess I shouldn't say there was a plunge implementation of Blackboard. It was actually a pilot. But you can also do a parallel implementation where you have two systems working simultaneously. Now, recently I was involved with a pilot for Blackboard Collaborate, which is a piece of software designed to, it integrates with Blackboard, but it does a lot of the similar functionality as Saba Meeting does, what used to be called Sentra. But they had both of them working in parallel. And you could, yeah, it was kind of a pilot of this new piece of software, but they were doing both of them to see which one do they want to continue using. So it was actually a test more than anything. But sometimes you need to do a parallel implementation to make sure that both pieces. Now, it's very expensive to do a parallel implementation. Very, very expensive. And can lead to a lot of issues. What happens if data is added into the old one, but isn't transferred immediately to the new one? Or what if information is added to the new one, but isn't consistent with the old one? And so you can have lots of issues by doing a parallel implementation, where both the old and the new systems are working simultaneously. All right, the dangerous one is the plunge implementation, and usually is more often used for small pieces of software rather than larger ones. The pilot is a popular one because that way a few people are using it. If it goes wrong for a few people, usually it doesn't destroy the entire company, right? And so it's something that you can easily identify and fix. You gradually add more users until you just cut off and everyone starts using it. There's also something called a phase implementation, where part of the new system are put in pieces, or parts, or some of the people are using the full system, and many of the people are still using the old system. And this happened to me once. I think it was a bank that I used to belong to, and the bank, when I lived in Alabama, the bank got bought. So this bank I belonged to got bought out, and so they were trying to consolidate all of their information systems to this new system. And they did a phased implementation on the banking software. Now, I moved during the middle of this phased implementation. So they transferred my account when I still lived in Alabama, but when I got to Louisiana, they were still on the old part of the system. And so when I went to go change my address for my bank, the new bank that had just bought them out couldn't transfer my my address. I had to go back to my old bank because I was in it was very confusing. And so phase implementation sometimes is a feasible option, but it still has a few small risks with it. That people, such as myself, who get caught kind of in this middle, in the middle of the phase implementation. But so none of these are exactly perfect, right? But you have to come up with the implementation that works best for whatever situation you're working in. All right. What are the tasks for system maintenance? So after you implement it, now we need to continue to maintain the system. So this is, you have to consider, and like I said, every piece of software that comes out is going to have bugs. But I think it's also important to realize that every system that comes out, there's always ideas of how to make it better. There's always things you can do to improve upon the quality of a system. And sometimes when you're developing a system, especially as you're running out of time, and you're nearing the end of your project plan and some things aren't finished, you just say, well, fine, we're going to prioritize which things need to get done. And if some things don't get done, we'll just do it in a later implementation or a new version of this piece of software. And that's why you see, software with 1.3.5 as the version of the system, because they do that all the time. They say, all right, these are, it's later implementations or later versions of this have either fixed problems, so bugs in the system, or have added changes or enhancements to the system. This is a very, very common way of dealing with this change management to a system, but also dealing with maintenance over time. So you have a lot of different versions of a piece of software, but as the higher versions usually means they're trying to fix bugs, that they're adding enhancements, and trying to make the software better and better over time. But maintenance is really kind of a misnomer, because work done during this phase is neither the fix, is either a fix to the system that it works correctly, or it's adapted to change its requirements. Okay, so it's really not so much that it's maintained so much as it is improved upon or fixed. All right. Also consider that the fixes, there's different levels and priorities of the types of problems with software. And they could be as simple as a patch or service packs or even a new release. But whenever there are bugs in the system, depending on how big the bug is, will determine how high a priority and how they roll out these new changes. All right. So back to the overall systems development life cycle. So we went through all the different steps. What I want to talk to you now is about what are some of the major problems. Where do things usually go wrong? So the requirements documentation, like we mentioned, is very, very difficult. So with that analysis and defining what are all the requirements. In part because, one, the business requirements change, but you could also spend too much time trying to define requirements. And there's actually a phrase associated with this called analysis paralysis, which basically means projects spend so much time on documentation of the requirements that you don't ever get started on the project. Now this might be a good case where a prototyping type system would work better, where you get started with the very, very basics and just start working with a prototype and changing it as you go and making it bigger and bigger and bigger. So there are ways of overcoming this, but it is always an issue that you could spend too much time trying to analyze your requirements, especially if you're dealing, let's say you're working with an ERP system, right? So this is a company-wide process, a company-wide implementation. You could spend all of your time trying to analyze the business processes, all the hundreds or thousands of business processes that are going on, but never get around to actually doing it, of implementing it. All right, second biggest problem, scheduling and budgeting difficulties. So time and cost estimates for large projects are often way off. And partly that's because the people who make these initial estimates know very little about how long it'll take or cost. Even though these people might be very experienced project managers. All right, so overall, the waterfall method, as we mentioned, as I called it before, the system. So, and this was kind of the traditional way. There are other ways, and we showed you one, rapid application development. There are other methodologies out there, but however, this is by far the most common and the most well known. And if you understand the importance of each of these components, understand different methodologies will contain these same components. They just might do them differently. So you're still going to have to do requirements analysis. You're still going to have to do component design. You still have to do the implementation. But sometimes it's not just a straightforward one, then the next, then the next, then you're done. All right. But the traditional waterfall is a non-repeated phases, but it rarely works really smoothly, and can cause the development team to go back and forth, raising costs and delaying the project. So oftentimes today there's a lot more that goes into it than this. But Hopefully now, though, you have a little bit more appreciation of what is involved with information systems development and why it's so important for you as a user to understand this process, because you are going to have an important role to play, particularly with the requirements analysis and with the testing. Now, the component design, you probably won't unless you actually go into information systems or computer science or something. However, I do know a lot of people who maybe go into like web development. Maybe they have a marketing background, deciding to go into web development. Well, you need to understand this process. I also know some accountants who go into more accounting information systems and again start learning this process. Or there's manufacturing people who start digging more into the systems side of things and start transitioning into a role of development. Okay, so it does happen. So it is, even if you may not want to at this very point in time, realize they're very easy to transition into this, especially as the development software becomes easier and easier to use. You're going to find, so for example, I teach my students how to use content management systems. Now, what's really incredible about a lot of these content management systems, so probably one of the more popular ones that you may have even heard of is something called WordPress, which was traditionally a blogging tool, but today can do so much more than just blogging. So why am I telling you about WordPress? Well, even if you don't create a blog yourself or your own website right now, do realize that the software development, it can be done without any coding whatsoever. You can create an entire website, and a fairly sophisticated website, with zero coding. So just because you're not a project manager doesn't mean you're not going to be involved with systems development. And in fact, that component design, you might have to make decisions about, okay, if I create this website, do I need search engine optimization? Well, great, there's a component or a plugin that I can install. But which one should I choose? Well, I have to understand the requirements for my business. But I can do it myself. And I can install the component and then implement it and roll it out so that everybody can start using this. So you don't necessarily have to be a computer programmer to be able to take advantage of this. All right? And I think we're going to see that more and more going into the future, where a lot of this software is being created such that users like you can do part of this process yourself, or almost all of this process yourself. I think another good example might be something called SharePoint, which is also attempting to make it easy for users to do the software development process. All right, so today we talked about what is systems development, and this is the process of designing and understanding the process for creating a new system, in particular how does the information system fit within that. But why is this so difficult and so risky? And it's because of all the changes that can occur throughout the project, because it's so difficult to plan, to really think through how long things will take and to adjust. We talked about the 5 phases of system development lifecycle, from the definition of the system to the requirements, to the component design, to the implementation, and then to the maintenance. We discussed what is a systems development and how it's accomplished. We've talked about what is the user's role in the requirements phase. We talked about how the 5 components are designed. We looked at how an information system is implemented, and we talked about the tasks for systems maintenance. And all of this is part of the traditional systems development lifecycle. However, there are other variations of it, such as rapid application development, which I gave you a little taste of. So at any rate, this is the big picture of what occurs within the systems development. And hopefully this can be an excellent way for you to get started in understanding the process. And so you can play an active role in making sure that the information systems are developed in a way that are beneficial to you and can help you be even more awesome at your job. All right, that's it for today. And